Errors are inevitable. They could be errors caused by the code that we write. They could be errors caused by the code that someone using our code writes. But many times, errors occur because of something outside of our control. Like, for example, let's say we're writing an application that interfaces with a database on a remote server. And for some reason, we can't access that server. It could be network issues, or the server could just be down. It could be a hardware issue. But it really doesn't matter to us because our application isn't working. Whatever the problem, it's not working. And there's nothing more annoying on the user's perspective to have an application that's not working, and on top of that, having cryptic messages. If we do it right, we can write an application that is going to fail because of some network or hardware issue, but it will at least fail gracefully so that we don't annoy the user. And to do that, we can use something called exception handling. It allows us to handle exceptions whenever they occur. At the heart of exception handling is the TryCatch statement. The idea being that we try to execute some code, and if an exception occurs, then we catch that exception, and then we can handle it. It's really easy to do, and by doing so, we make our code higher quality. So let's look at an example, and I know a perfect place to use exception handling. It is our isPolygon static method inside of the shape utility static class. This is also an extension method for shape objects. Now you might think, where can this code fail? Well, we are getting a shape object to do something with. We use the sides property, and it can be possible for shape to be null because we can create a shape variable but never create an object to assign to that variable. In that case, that variable would be a null object. So if we pass a null object to this isPolygon method, our code is trying to use a sides property, and a null object does not have a sides property, so an exception is going to be thrown. So this is a great place for us to do exception handling. Now, of course, we could do our own validation, but validation and exception handling give us two different results. The idea behind validation is we validate input, and if that input isn't what we want, then we stop code execution. The idea with exception handling is when an exception occurs, we handle it in a graceful way, and then we continue to execute code. So, yeah, we could validate it, but we could also handle the exception. And since we are talking about exception handling today, guess what we're going to do? Okay, so before we actually get into the try and catch statement, let's see what happens when we use a null object with the isPolygon method. So first we need to create a shape variable. I'm going to call this null shape. Now we do have to assign a value to null shape. We can't just declare it because our code isn't going to compile. And I'll just show you that. So let's write this to the console, null shape, and then we'll call isPolygon, and then try to run this. Now, as I said, this isn't going to build, and if we look at the error message, it's because we haven't assigned a value to null shape. The compiler knows that there's no value here, and that we are trying to use the isPolygon method on a variable that does not have a value. So let's run this again now that we have assigned null to the null shape variable. And there we have an unhandled exception. This is the type of message we do not want the user to see. System.null reference exception. Object. Reference not set to an instance of an object. This makes sense to us, but it doesn't to a user. All they know is that their application failed, and really all that they want to know is what's going to happen because of this failure. Well, if we use a try-catch block, we can gracefully fail within our application, and we can let the user know what's going to happen. So let's look at the try-catch statement now. The TryCatch statement is made up of two code blocks, one for try and one for catch, and we want to put the code that can fail, which is line 17, the calling of writeLine and using the null shape variable, putting this code inside of the try block, so we want to try to execute it. Now, I typically use all of the lines of code that are related to the line that can fail inside of the try block. It could be right or wrong, I really don't know, but that's just my personal preference. We can specify the null shape initialization outside of the code block if we wanted to, because that's not going to fail. But I like to keep the code together, so I put that inside of the try block as well. So the try block first starts with the try keyword, followed by an opening curly brace, the code that we want to try to execute, and then the closing curly brace. And that's it. That's very easy to do. Now we want to catch any exception that may occur with this code. And to do that, we use a catch statement. And then we have a set of parentheses. Now this is kind of going to look like an if statement, except we're using catch instead of if. But this is not a condition. This is a lot like a parameter for a constructor or a method. We specify the type of exception that we want to catch. In this case, I've specified exception. So exception is the base class of all of the other exceptions. So it doesn't matter what exception is going to occur, this catch block is going to catch that exception. So other than the difference of the catch and then the exception parameter, if you will, it looks a lot like an if statement. So inside of this catch block, we do not have access to any of these variables. So if we do want access to the null shape variable, we do have to define that outside of the try block. Like for example, if we tried to do null shape, that's not there in IntelliSense, so we don't have access to it. But we do have access to this variable that we have defined as a quote-unquote parameter. So if we wanted to, we could use this as any other type of value, and there's a message property of this object that we could use. So we could do something like console.writeLine, and then write that message to the console. Now, this isn't going to be overly helpful for the user. Object reference not set to an instance of an object. That means something to us, not to the user. So we might want to say something like this. We cannot evaluate the polygon, or the shape. Let's do shape. The shape at this time. In this way, we display a message to the user, but then the code execution can still continue. And we might want to tell them, you can try again later, or, there's some technical issue occurring. Whatever we wanted to tell them, we could tell them. But the point is, our code has failed, but we did so in a graceful way so that we let the user know, hey, something happened here. Whatever you requested, we can't give you right now, but you can still use the application. As far as this code is concerned, we've done our duty. We have caught the only exception that can occur, we let the user know, and then we went about our business. But there are going to be times when you will write code that can fail for a variety of different reasons. Like, for example, let's say you have some code that's supposed to go out to the internet, grab something, and save it to a file on your computer. Well, there's two things that can go wrong. There could be a connectivity issue with retrieving something from the internet, and then there could be a privilege issue for accessing a file or trying to access a file that you don't have privilege to. So those are two exceptions that could occur in that particular scenario, and you would want to handle those two exceptions differently. Well, we can do that because C# allows us to have multiple catch blocks for different types of exceptions. Well, let's use that idea of going out to the internet, grabbing something and saving it to a file as an example. Naturally, we're not going to write that exact code, but we can simulate the exceptions that would occur by simply just throwing those exceptions. So let's replace our shape code, and let's throw a new system.net.web exception. This is the exception that would be thrown if for some reason a resource didn't exist on a server, or there was some connectivity issue, there was a timeout. There's a variety of reasons why we would get a web exception. So that would cover that. We would also need to throw an exception for the file system. And we go to system.io for that, and there is the IO exception. And like the web exception, the IO exception handle is thrown for a variety of reasons. A file couldn't exist. Well, let's just make sure about that. There might be a file not found exception. That would be one. Let's do that. File not found exception, because that's a little more specific than just the IO exception. The IO exception is the base class for a variety of IO errors. So the file not found could be caught by an IO exception, or a directory, or a privilege issue, or a variety of other different issues. Now, both of these exceptions can be caught by the catch block that we already have, because these are all derived from exception. And for the most part, we do want to have an exception block, because sometimes we might forget to catch, all of the exceptions that could occur. And by putting an exception block, we have guaranteed that we will catch every exception that occurs. So we'll leave that, but we also want to catch these specific exceptions so that we can handle them differently. So we will do catch, and then we want to catch the web exception first. We'll call this WebEx. And then we want to do something whenever we catch this exception. So we can do something as simple as writing something to the console. We cannot retrieve the requested web resource. That's pretty specific. So that would work. And we also want to do the same thing for the system.io.filenotfound exception. So system.io file not found exception, we'll call this file X. And we will want to write a message as well, console.writeLine. We cannot find the file you requested, or the file needed to save the document. That'll work. And then we will leave the exception. We might want to change. We'll just do something happened. Why not? Okay, so whenever we run this code, we are going to see the catch for the web exception. And that is going to be it. We won't see the one for the file not found, because once we hit this line of code, this exception, it's going to be caught, and then it's going to continue executing. So once we hit an exception, that's it. We won't catch any of the other exceptions because we will be out of the try block. So here we go. We cannot retrieve the requested web resource. So we have caught the web exception. Let's comment this line out so that now we can catch the file not found exception. And there we go. We cannot find the file that's bad grammar. We cannot find the file needed to save the document. So that works. Now let's throw a completely different exception. One that we haven't specified as web exception or file not found. It really doesn't matter, just an exception. So let's throw new out of memory exception. That sounds good. And then this will be caught by our generic exception handling. So if we run this, we will see something happened. There we go. Something happened. So this is essentially exception handling. Oh, there's one other thing. There's the try, and then there's the catch. And in this case, we have multiple catches to catch different types of exceptions. But then there's also a finally block. And the finally is used regardless of if something is caught. So we could have perfect code inside of our try block, but whatever we specify within finally is going to execute as well. So write line, we're in the finally block. So we are still throwing an exception. We will see the message, something happened, and then we will see we're in the finally block. So there we go. And if we have perfect code, let's comment out all of the exceptions. We will see we're in the finally block. So finally is going to execute regardless of if we catch an exception or if we don't. And the finally is useful for when you need to do any type of cleanup. If you are accessing a database and some error occurs because of accessing that database, you can close the database connection inside of finally if you wanted to, but there's actually better ways to connect to databases than using the finally clause. So that is exception handling. Try, catch, and finally. And if you do it right, you can fail gracefully and still have an enjoyable app that users will want to use. Tomorrow we are going to finish up the course by talking about debugging. Debugging is very important because there are going to be times when you have a bug in your code. I always have bugs in my code. The people I work with always have bugs in their code. Even people writing software that you are using have introduced bugs into their code. And sometimes it can be easy to find. Other times it's not so easy. And we have the ability to debug our code, to step through line by line and see each line execute and see what's going on. So it's a really cool feature that most development environments have, but it's really great in Visual Studio. So we will talk about that tomorrow.